My name is Borntraeger, and I'm the maintainer for KVM on IBM Z, or we know it as S390 in the Linux tree. And I work together with a bigger team in the Böblingen lab in Germany, and we are doing all the low-level stuff for S390, so Linux kernel, KVM, GCC, libc, all the low-level stuff, distro enablement, and so on. I work for KVM since about 2007, so actually quite for a long time now. I had some breaks in between, did some compiler work, but I'm back with KVM now, so for a long time, and this is what I'm going to do. Some greetings from our legal department as well. Warm welcome. So what is the motivation of that talk? As I said, I'm the maintainer for KVM on S390, and that's why I mostly focus on that platform. So I have to take care that S390 KVM continues to work, that our performance is good, that we exploit new hardware features and these kind of things. At the same time, I actually try to stay up to date with what's going on in KVM. So whenever time allows, I try to follow the work of other people's. And I've quite often seen changes from newcomers or people that are working on other architectures that do specific things that were written in a way that was only working for one architecture, usually x86. And quite often it turned out that this kind of feature would actually be useful also for other platforms like ARM, Power, or S390. So this was the motivation. And I'll give some kind of history, how KVM evolved regarding multiple architectures. I give some examples of good and bad things, and also some outlook and what can we do in the future. Okay. The first steps of KVM were done in 2006 by a young startup from Israel called Commonality. And it started as a device driver. That was how RBKBT then called it, specifically for the 32 and 64-bit version of x86. And the first version was actually even Intel only. So they had plans to add AMD support later on, because at that point in time, Intel and AMD both provided hardware extensions to do hardware-supported virtualization. And by having an Intel version and an AMD version, that actually drove some first kind of factorization. So the code already had to be prepared to deal with two different kinds of things. But still, the device driver itself was very x86 specific. And when you have a device driver, that usually is for that device, and you're not going to extend it to other devices. But as it turns out, the interface of the KVM device driver was actually flexible enough and generic enough to be useful for other architectures. So there was interest from the Itanium forks from Intel, there was interest from the PowerPC forks at IBM, and also interest from the S390 forks at IBM. So in the first KVM forum in 2007 in Tucson, people talked about what can they do, and the decision was made to actually refactor KVM, to basically split out the common code from x86 specific code. And so there was some kind of joint work, and probably one of the times where the work between IBM and Intel was as close as possible as it can get, because the Itanium forks did a lot of patches, and we did review them, and vice versa. So when you look back at these commits, you see a lot of reviewed by commands from Intel for our patches and vice versa. And that actually worked quite well. When you look at the diff stat, I mean, we had about 50 commits overall of refactoring. So we didn't do that in one big chunk. The goal was to keep the whole thing running all the time. So we had split it in around 50 different commits that split KVM piece by piece into a common part and an architecture part. And about half a year later, this is a screenshot of a blog post from RBKBT where he compared the code size of different architectures. KVM was basically everywhere. I know the ARM and MIPS forks might disagree here, but back then there was actually no hardware support in ARM or MIPS to run virtualization. And in fact, that was actually also true for PowerPC, because the first PowerPC port was not for the big IBM systems like Power 7, 8, or 9, but it was for the tiny little PowerPC 440, which was an embedded controller. So the PowerPC port was purely a trap and emulate version of KVM with no hardware support at all, interestingly enough. Okay, so let's now look into components. I mean, this was mostly kernel. Let's also look into what other components do we have in KVM where we actually could share code. As I said, the KDM kernel module, or the KDM driver, is actually the closest one to the hardware. So we would expect that there's the least amount of commonality between different architectures. And my expectation is that if you go along, the next step is basically the QEMU user space. That is also relatively close to the hardware, but it already uses an abstract interface, system calls basically. So it should not be worse, it should be better in terms of common code usage. And when you then look at libvirt, that is even farther away. So it also uses system call interfaces, but the interface to the virtualization part is then done via the QMP interface, so JSON-based, and you would expect that the amount of shared code is actually even higher. And when you look beyond that, OpenStack, Word Manager, Ref, all these kind of management stacks on top of libvirt, things are getting more common even more. So I did a quick check comparing QEMU and kernel. The charts are a bit rough. They're actually lying. I mean, I only checked the files that have KVM in the file name. So I did not consider the memory management that is actually common. And KVM heavily relies on building upon the host scheduler and building upon the host memory management. So just look at the KVM code here. And as you can see, the kernel is actually pretty distributed across architectures with a pretty small piece of common code. When you look at QEMU, here these things are actually much better. So you have a much bigger range. The blue one is basically the common code, and the grayish ones are the different architectures. What I find interesting is that when you remember the blog post from Additivity, there have been large differences among the architectures. But in QEMU, it turns out that the size of the KVM-related files are actually pretty similar. That was pretty unexpected for me. I do not have charts for libvirt because in libvirt, there are actually no real files specifically for an architecture. So you have code that basically knows different kinds of devices, but it handles basically all of them. So you have code that, for example, deals with Word.o SCSI, and that code knows about Word.o PCI and Word.o CCW, different kinds of things, but it's all the same code. So it's pretty hard to actually just see how much common code is here. But the fact that there's no separation on the file level actually indicates that things are even better in libvirt regarding communality. But let's go back to the kernel. I mean, I was actually shocked when I saw that slide because we are talking about less than 4% commonality when you just count the lines of code. And that looked pretty bad to me. So I looked a bit closer. Let's first start with the architectures. I mean, the biggest architecture is obviously x86, and there are several reasons for that. I mean, x86 KDM still supports hardware without nested paging. It supports basically all kinds of addressing modes, 64-bit, 32-bit. It has a lot of emulation to run all kinds of Windows. So the KDM part of x86 is pretty much complete. You can run almost any x86 capable operating system. The second biggest architecture is PowerPC. Here is also something to consider. PowerPC still contains the old code from back then that is based on the PowerPC 440. It is now called E500, so Freescale basically took the original code and modified that to also be able to run their embedded cores. And then there's the Book 3S, which is the big IBM systems, Power 8, Power 9, and so on. And then MIPS, S390, ARM are basically all in the same ballpark. The interesting part with ARM is that actually 2/3 of the ARM code is about the interrupt controller. So, and quite frankly, this is a code I necessarily do not want to share on S390 for obvious reasons. But again, we had less than 4% commonality. So my question was, did it actually get better over time? So I checked the last releases, and it turns out, no, it did not get better. In fact, the bluish line here is the amount of code that are common across all architectures, and the red line is the code within the architecture files. And as you can see, the architecture-specific code is growing in a linear fashion, but it's growing pretty heavily, while the common code almost stays the same. We have some jumps in here. As you can see, around, I think, 3.8, 3.9, ARM and MIPS were added. Somewhere later, Itanium was removed. This is something I hear from several kernel people that they actually would like to remove Itanium also beyond KVM, but there seem to be users, so it's not that easy. And interestingly enough, the removal of Itanium actually led to a case where the common code part was actually reduced again. There was code for device assignment, assigning PCI devices to a guest, and that was used for Itanium and x86. And after the removal of Itanium, it was basically only used for x86, so we moved that to the architecture code. When I first saw that slide, I found that a bit depressing. So then I looked further. So why is it that way? And there are actually 3 kinds of things in the KDM kernel module. There are things which are really common across all architectures, and that's basically everything that is related to user space interfaces, the system calls, the I/O controls, debugfs, these kind of things, and code that is related to that. So the lifecycle management of CPUs or the lifecycle management of guest. This is basically one of the most common I/O controls, create VM, create vCPU, and so on. And therefore, these things are obviously common. Then there are things that are partially common, where there is some common code with some architecture backend. And this class is more of the things that have some kind of internal state attached to it, either guest state or host state. So these things share a lot of common code, but you need some kind of architecture knowledge in there. And the biggest part is then the architecture code. And obviously, here are things which are really hard to share. You usually have to set up control blocks in KVM to drive the hardware. And these control blocks are hardware specific. There's no way of ever being able to share those. Nested virtualization is obviously very hardware specific. There is no way of sharing these. The emulation of the memory management unit, it's pretty much hardware specific, and so on. And also the counters of KDM stat. We have 2 or 3 common ones, but the big ones are really hardware specific. And basically any hardware enablement, I mean, that's what we do. When you look at ARM, at IBM, at Intel, when we provide patches, we often try to get our CPU features enabled. And of course, these are architecture specific. But still, wouldn't it be nice to actually identify these things that could be shared across architectures? And why didn't it work out so well? So what kind of problems did we had? Let me give one example here. There is a feature called halt polling, and that feature is part of KVM, and what it does is it optimizes the performance for workload where the guest CPU is basically stopped for a short period of time. And the polling the reason for polling is actually that quite often when the CPU goes to sleep, it is woken up again pretty quickly. And and that has a lot of latency when the guest CPU sleeps and the host puts it to sleep as well, and it has to wake up again very quickly. The latency is pretty large. And to avoid that, KDM basically spins a bit after the CPU goes to sleep. Okay, turns out that this does not work overall. When I first tried it on the S390, I had basically lots of guest CPUs running at 100% all the time. And the problem here was that on S390, I/O interrupts are floating interrupts, so they are pending on every CPU. So the logic in that code actually decided, oh, the polling was successful, and it decided that on all CPUs, even though the interrupt was only delivered at one CPU. We could actually fix that. We had architecture callbacks, and so things are fine. Another thing, Power actually has a private copy of HAL polling because it turned out to be actually hard to have an architecture independent way of HAL polling for the way how Power manages its SMTs, so its threads. So here's a case where we actually were not able to use a common code, and Power had to have its own private copy because making common would have made the code more complicated. What is about architecture review? And so I just grabbed for a reviewed by into different architecture codes, and it turns out that we are not only not that good at sharing code, we are also not that good at doing cross-architecture review. Most of these reviews are pretty much inside the silo, with one big exception. Thank you, Red Hat, for doing cross-architecture review. But other than that, this is really inside the silo. So we should actually do more cross-team education. And when you look at KDM Forum, here, these things work pretty well. We had lots of talks in the past from AMD, from Power, from ARM, from Intel, from S390. We have lots of talks this time. So we should use that chance to actually talk more to each other. And I actually want to propose a BOF session about that topic. What can we do to improve architecture similarity, or maybe just exchange? What kind of features do we have? And can we basically talk to each other and get something out of the other architectures, get some ideas? But not everything is bad. There are also successful changes. For example, the time accounting. As you might know, you not only have now user and system time, you also have now guest time that is measured for your QEMU processor. So you can directly see, is that CPU spending time in the guest or in the host doing work for the guest? So I have here an output from Systat, which shows some kind of guest percentage. And this code is actually pretty generic and handles all kind of cases with word CPU accounting, generic word CPU accounting for Power in S390. It works for the no-hertz case. So this is really something that seems to work quite well. Sad thing is, when this was introduced, ProcPS, the top, was still maintained by a maintainer that was not very responsive. So there is no support for that in top yet. Now that we have ProcPS NG, we might actually follow up on that again. Other things that are good is sharing ideas. If you know me and have seen my presentation 2 years ago, one of my hobbies is to optimize the guest entry-exit time. So I try to squeeze a lot of things. And one of the things I've done was to push out the loading and reloading of the FPU registers more and more far out of the kernel. So when we first started, we did the loading and reloading of FPU at guest entry and exit. Then we moved that out to vCPU put and get, so basically on rescheduling and going out of the KVM. And finally, I actually even pushed it even further into the I/O control path. So I only load the floating point register basically when going into KVM and going out from KVM. And last year I talked to Rick van Riel about that. He liked that idea, so he did the same for x86. So we can actually share ideas. Another thing, asynchronous page faults. This is something that IBM had for quite a long time with CVM, and we tried to implement the same interface with KVM. But meanwhile, x86 had implemented a similar scheme called async PF. And when we sent out the patch of our interface, AVI basically asked the only right question: is this actually duplicating code? And yes, it did. And we were able, by doing some kind of small refactoring, to reuse the other code. And last thing I want to talk about, this is an idea that did not yet work out quite fine. We had guest page hinting since 2005 on IBM Z, and there have been numerous tries to also have guest page hinting on x86. There's a talk about that, I think Friday. And I think we have to see if we can actually make use of some commonality here, or if that will never be common. But you see my point. There are several things where different architectures work on similar things at the same time. Okay, last but not least, I want to talk about interfaces. Oh, sorry, was too quick. When Word.0 was first introduced, it was basically a very generic interface. So you could actually implement Word.0 over a serial line and these kind of things. Or as I put in, over pigeon carriers, if you want to have that. But sooner or later, it was decided we need a spec. And during specking of Word.0, it was decided to do it with a PCI interface, because it is much easier to add a PCI driver to Windows than to add a new bus type. Problem was, SU90 had no PCI back then. So we then actually discussed this and provided our own backend, still reusing most of the code, but we now have basically a different interface into Word.0. Does it cause any problems? And yes, it does. Here I have 3 examples here, 3 libvirt commits. And the same is actually also true for QEMU. The first commit basically added Word.0 SCSI support in libvirt. Only for Word.0 PCI, so it didn't work for SU90. We realized that a bit later, so we added Word.0 CCW support in libvirt to have the same on SU90. And some years later, somebody realized, okay, we have actually a lot of code duplicated here. We can actually fold it together. So by having multiple interfaces for the same common code, you still have the danger of actually getting things duplicated. And we have to pay attention here. Okay, future development. I just want to show 2 things that happened this week and last week. There was a patch on the list introducing an interface under this hypervisor. And the good thing with this patch is it tried to do an interface in the same fashion as it was available under Xen. So that is really a good thing. Somebody tried to have the same interface on different hypervisors. The bad thing is that the whole code was fully x86 specific. But as it turns out, it should be relatively easy to actually get that code in a fashion that we can use it on all architectures. So having the same interface on all architectures would be really a good thing. Another interface that was coming along just this week, read-only enforcement, so that the guest can basically harden itself by telling the host, please make that page read-only, and that is also x86 specific. I have no idea yet if we can make that cross-architecture, but at least we should try. And there's a steady flow of such kind of changes, and that brings me to the summary. We should really try to improve the discussion among the architecture teams. And for everybody else, please do not assume everything is x86. I mean, you might know ARM, but there are even more. There's Power, there's MIPS, there's S390. And if done right, it can actually be shared with other hypervisors like Xen, or maybe we can do some interfaces that look like Power VM or ZVM. Where it makes sense, why not? But at the same time, sometimes sharing too much hurts. So it will not be possible to share everything, as you have seen with the halt polling code. So if it doesn't work out, then it's fine to have non-shared code. And if you're interested in that topic, please see my BOF session. I will film that later. Time is running out, and so thank you very much for your attention, and have a nice KDM Forum. Are there questions? No?
More like a remark. Sometimes it's not quite obvious that something is architecture specific. For example, if I'm looking at the VFIO stuff, we have our PCI, which is mostly cross-architecture, but there are also architecture-specific implementations, like CCW also and so on. And you also should consider, if you are doing some VFIO work, that you may have not only VFIO PCI, but other stuff, which is might be a bit strange. Sometimes it will be hard to accommodate those other weird implementations if you are doing new feature, but it's really good to keep it in mind that they exist.
Right. I can only agree to that. I mean, time is running out, but we have a panel session afterwards, so you might just stick in a question in there. Or just please contact me on the floor.
I think you can move it to the BOF session, right?
Yeah. Thank you.